In section 11 of chapter 2, we're going to be graphing rational functions with individual transformations. As always, we do not know what the graph of the parent function, the mother function, looks like. We're going to have to start with an xy table. So we're going to pick our inputs, and we're going to find what the outputs are. So here are our inputs. We're going to input the value x equals 3, 2, 1, and 0, as well as -1, -2, and -3. When you plug in 3, you're going to get 1/3, 1 over 3. So you're going to go right 1, 2, 3, and up 1/3, which is like, I don't know, somewhere around right there. Then we're going to plug in 2. We're going to get a 1/2. So when we go right 2, we're going to go up 1/2. And then when we plug in 1, you're going to get 1 divided by 1, which is 1. So right 1, up 1. And then 0 is where something unique happens, because we're going to get 1 divided by 0. This is one of the 2 golden rules of mathematics. We already talked about one early in the chapter, which is you cannot square root a negative number. But the other thing you're never, ever, ever allowed to do is you cannot divide by 0. As a little side note, wondering why you cannot divide by 0? If you have something like 8 and you divide it by 4, the answer to that is 2. But the reason the answer to that is 2 is because if you take the solution and you multiply what you were dividing by, you would get the numerator. Now if we start analyzing what happens when you have something like 1 over 0, and we do not know what it is, another way of interpreting that is asking, what number can you multiply by 0 and get 1? But there's a golden rule in mathematics that anything times 0 is always equal to 0. So that golden rule in mathematics, where you're multiplying by 0 is always equal to 0, is the same thing as saying you can never divide by 0. That's why at x equals 0, it is undefined. What that looks like on our graph is there's actually going to be something that's called a vertical asymptote. It's a vertical dotted line. What that represents is that represents a location that the function does not exist at. It's going to get closer and closer to that location and never ever touch it, just like exponential functions we did earlier in this section, or in this chapter. When I plug in -1, you're going to get 1 divided by -1, which is -1. So if we go left 1, we'll go down 1. And then if we plug in -2, we would get -1/2. So if I go left 2, I'll go down 1/2. And then if I did -3, I would get -1/3. So if I go left 3, I'd go down 1/3. Now, technically this is enough to graph, but we're kind of missing half the picture. So what I'd recommend is actually doing an additional t-chart that's going to look a little bit different. So in this t-chart, we're actually going to kind of ignore where the 0 would be put at. We're just going to be focusing on another counterpoint, which is we are going to be looking at not 3, 2, 1, and -1, -2, -3. We're actually going to be looking at the reciprocal values, because when you look at the reciprocal values, something weird is going to happen. So instead of 3, we're going to type in 1/3. Instead of 2, we're going to do 1/2. And instead of 1, we're actually not going to do that one at all, because the reciprocal of 1 is still 1. Same thing with -1, we're not going to do that one either. But the -2, we're going to do -1/2. And the -3, we're going to do -1/3. So we're substituting those into the mother function 1 over x. And when we do that, for 1/3, you're going to get 1 divided by 1 over 3. So we're going to have a fraction inside of a fraction. And for those that have forgotten, how do you deal with a fraction inside of a fraction? The way we deal with that is we take the numerator and multiply it by the reciprocal of the denominator. The reciprocal means you're going to take the fraction on the bottom and flip it. So instead of 1 over 3, it's going to become a 3 over 1. When you multiply 3 over 1 times 1, you're going to get 3. So the answer to that is 3. Therefore, when we go right 1/3, we're going to go up 3. So that's going to give us something about right here. And then when we do 1/2, I'm going to put this down here a little bit, that's going to be 1 over 1/2. Following the same rules, we're going to go 1 times the reciprocal of the denominator, which is 2 over 1. That will allow us to get an answer of 2. So when we go right 1/2, we're going to go up 2. And hopefully you can start to see some of the patterns that are emerging, which is all of the coordinates from the original t-table have just swapped places. So when I do -1/2 and -1/3, all I got to do is take the swapped x and y values from the initial t-table that we did. So this will become a -2 and a -3, meaning we're going to have a coordinate at left 1/2 down 2 and left 1/3 and down 3. And now we're going to get a much better understanding of what this graph looks like. It's going to look something like this. Now the last thing I want to touch on is something that you can kind of see happening here, which is as you are approaching it, think of this as a road. As you're approaching it from left to right, you're going on this road, notice we do not touch that purple dotted line, the asymptote. We're getting closer and closer, but we're not going to touch it. And then over here on the right side, we're really close, and then we're just like not going to touch it, but we're getting further away. But that is not the only asymptote that this graph has. There is another asymptote that we might notice, which is it has an asymptote at the x-axis. That is another location that the graph is getting closer and closer to and not touching. So this function has a horizontal and a vertical asymptote. So it has what is called a domain and a range restriction. The restriction for the domain is this function exists everywhere to the left and right except at 0. It does not exist at x equals 0. That is the domain restriction. For the range restriction, this function exists at every single height except at y equals 0. Y equals 0, the function also does not exist. So for domain and range, which we'll get into later in the year, there are two restrictions. The range is y cannot be equal to 0. The domain is that x cannot be equal to 0. It's an important thing for us to note where a function does, and more importantly, where it does not exist. The last note in this section is that when you go across the stretch and compression factors, I will note it does drastically change the coordinates, and I'd recommend doing an x and y table for at least the few first problems you see until you get the pattern that emerges from those. Other than that, you should be good to go and ready to start graphing these rational functions.